Hello guys, welcome to another video of Sigma Tech Tricks. On today's video we are going to repair a laptop. The model of laptop is t420. As you can see this is the laptop which customer brought, and the problem in this laptop is when we plug the power cable charger, the charger light goes up. That means there is something shorted inside the laptop. So today we are going to show you total from opening to till repair, how we repair it. So let's see how we are going to repair it. So guys, we will keep our DC power supply on 19 volts and ampere is on 5 amp, and now we will connect our charger to the laptop. So let's see. You can see on the DC, as soon as we connect, the light jumps to CC. That means the board is shorted somewhere. The ampere is rising more than 5. Okay, so let's open the laptop and start repairing it. Okay guys, the board is out now. We'll completely remove the board from the panel. So the board is open now. Now we need to remove this DC jack. So board is dirty. First we will clean it and then we will inject the voltage and see if there is any component heating and or what causing it to go short. Okay, so let's clean the board. Okay, so we have cleaned the board. Now we'll attach the DC jack to the board and then we'll start probing. Now before we start, we will remove the processor. As we know, the board has a shorting, so until unless we remove the shorting, we cannot put the processor, as we have to inject the voltage. It's a first generation, I guess second generation processor, second or third maybe. Okay, so as per my experience, previous experience, I found most of the time this board get shorted due to these caps. As you can see, these caps, these larger caps, these 3 caps, or maybe this area, most of the time I find short in this area only. So let's find this time whether any of these caps are shorted. First we will do cold checking with the multimeter. we have kept it multimeter on the buzzer mode. So let's start by checking from this cap. So as you can see, this cap shows 001 resistance. The other one also same, and the last one also shows same thing. So first we will remove these caps, or either we will inject the voltage and see whether any of these caps are heating or not. So let's put a voltage and see whether these are the faulty caps or any among this is the faulty. So let's first put a voltage on it. Now before injecting voltage, we must know where we have to inject the voltage. Okay, so to do that, first we need to find out 19 volts, the main line, which is start from the DC jack and then it goes towards this way inside the board. Okay, so let's find out this 19 volt goes to which lane. Okay, so we'll check it out here. There doesn't seem any line going here, so maybe backside. Okay, so here this is the line. First the 19 volts come to this part, and from this resistor it is being distributed to entire board. So let's confirm once. First we will keep our black probe on the red wire, which is here. We'll keep the probe here on the red wire, 19 volt main supply, and then the other probe behind this board here. As you can see, there is a fuse here. After fuse there is a MOSFET, and then again there is another MOSFET. The voltage travels from this fuse, from the DC jack to this fuse, and then this MOSFET, from this MOSFET to this MOSFET, and then it goes to the resistor. From this resistor the voltage goes to this MOSFET. So here if we check it out, this will give us beep to the ground. As you can see, that means there is a shorting in the 19 volts line. So first we will check it out, the lane. This is to just show you guys. We will keep the probe here on the red, and then we turn it back. As you can see, if I touch the fuse, this is connected to the DC jack. Now from the fuse to this MOSFET. There is a continuity, and from this MOSFET to this MOSFET, and from this MOSFET to the resistor. Now we will remove this resistor and we will give the voltage here, and then see which part is heating in the board. So let's remove the resistor and inject the voltage. So we will apply some flux here. Now you can see we have removed the resistor. We will keep the multimeter on buzzer mode again, and we will check it with the ground. Black probe on the ground, and one side of the resistor if we check, we will find value, no beep sound. And the other side of the resistor, yes, the downside. So here we are going to inject the voltage with ampere, and let's see what component is going to hit. Now here we have two wires connected with the DC. This ground, we will plug it to the body of this board, that is ground, and this second one, the main wire, we will solder it here, downside of where the shorting is there, and we will switch off the DC power supply now. Okay, so let's solder it. Now we have soldered the wire. We'll clean it up little bit, and now we will inject the voltage. And now we will decrease the voltage first before turning on the DC, and keep the ampere 5 only. And now we'll turn off the DC. Okay, slowly we'll increase the DC, increase the ampere, voltage. So we have given 1 volt. In 1 volt it shows 1.3 amp. Now we will check it out if anything is heating. So as I told, this is the suspected area. We will touch it here first. No heating. In 1 volt, 1.4 amp, there is no heating found. Okay guys, I think we may need to increase the ampere. So let's increase the voltage. Now it is almost 2 volt and ampere is 2.10. Now let's check it out. So as I suspected, this is the cap which is heating. We have raised the ampere little bit more. You can see 2 volts, 2.1 volt, and the ampere is going around 3.3. On this much ampere, this cap is heating. Okay, so let's remove this cap and we'll check it whether the shorting has gone or not. We'll turn off the DC, and now we will remove this cap. So now we have removed the cap, and now we will check with the multimeter whether the shorting has gone or the shorting is still there. You can see the multimeter now. We'll check it out. As you can see, the value has came. That means the shorting was there in this cap only. Now if you check it out other caps, there is no shorting. Okay, so this cap was creating the problem. Now we will replace the same capacitor like this from a different board, can see it. We will replace this from a different board and we will turn on the board. Here you have a different board where the similar cap is there. We will remove this capacitor and we will put it back into this one. So let's remove the cap. And put it back to the same position where earlier capacitor was there. Okay guys, so the capacitor has been placed properly. As you can see, it has been placed perfectly. Now let's remove the wires. And put back the resistor. Okay. Now we have placed the resistor as well. So let it cool down. After that we'll inject the voltage 19 volts and we'll check it out whether the board is getting on or not. Now it has cooled down. Let's put the processor and check it out. We'll just put 2 screws for checking now. And we'll put the RAM. And we'll connect the screen. And now we'll inject the 19 volts. So we have kept the DC at 19 volts, as you can see. And now let's put the charger. As you can see guys, there is no shorting and the board has turned on. You can see the fan is spinning. This is second time turning on. Okay, now you can see the display has come and the fan is running. So this is how we repair laptop motherboards at our shop. If there is any laptop for repair inside and around Bangalore, you can contact us on the given number below on our description. So guys, as you saw how we fix the laptop, but remember one thing, that this is not the case in all the laptops. This is the easiest case we showed you, that if there is something like this occurs, you can easily find the short, but most of the cases will never be the same. Okay, if you are doing it, be careful and then do it. If you found this video interesting, useful and informative, please subscribe my channel and like the video. Thanks for watching. Have a nice day.